we're fortunate we've got this incredible team of people in the business that are really focused on delivering change or value. We have this internal conversation around treading lightly. Everything we're trying to do is actually develop technology that enables humanity to do more with less for longer.
The New Zealand Business Podcast, brought to you by Gorilla Technology, your strategic and proactive IT partner.
Greetings and welcome. I'm your host, Paul Spain, futurist and chief executive at Gorilla Technology. I love seeing individuals and their organisations thrive. The New Zealand Business Podcast is all about this, through sharing the business, leadership and innovation insights of others. So whoever wishes to listen in and action what they learn will up their game and their impact, whether that be locally in New Zealand or on the global stage. In this episode, I sit down with Christopher Boyle, co-founder of Fabrum, one of Canterbury and New Zealand's most innovative high-tech companies. Christopher graduated in electrical engineering from the University of Canterbury and spent years working in power systems around the world before returning to New Zealand. In 2004, he and co-founder Hugh Reynolds launched Fabrum. What began as a two-person startup has grown into a team of nearly 100, leading the way in green hydrogen solutions, from small-scale liquefaction systems and composite cryogenic tanks to hydrogen refueling infrastructure for heavy transport, aviation and mining. In 2023, the company secured $23 million in a Series A funding round led by London-headquartered AP Ventures, along with investors from Japan, Australia and New Zealand's own K1W1. In our conversation, Christopher shares Fabrum's journey from a passion for engineering to becoming a global leader in cryogenic and composite technologies. He talks candidly about the challenges of innovation, surviving market shifts, and the vital role of Kiwi ingenuity in engineering and building world-class technology from Christchurch. The New Zealand Business Podcast is proudly brought to you by Gorilla Technology, the information technology services provider who makes tech easy, productive and secure for mid-size and smaller New Zealand organisations. If your IT isn't helping your business move forward fast enough, then visit gorillatechnology.com and get in touch. Welcome to the podcast, Christopher Boyle. How are you?
I'm great, thanks Paul. Thanks for the opportunity to have this chat.
It's a real privilege to be back in Christchurch again, and particularly here at Fabrum. So, Fabrum is a name that's sort of come up over a period of years as being one of the standout companies here in Canterbury. I think a lot of people probably don't know too much about the story. So maybe you could sort of walk us back to your founding days. You've been in business a little bit over 20 years. So how did things begin?
April 2004, my now business partner. Then we were just mates that met racing motorcycles at Canterbury University. Hugh Reynolds, a specialist in composite technologies with a mechanical engineering background. I'm a heavy current power systems electrical engineer, both of us out of Canterbury. We knew each other for a period of time, talked about business for a number of years, and then in 2004 came up with a couple of ideas and thought we should give this a go.
And so what were those initial ideas? What were those initial opportunities that you saw?
My professor from university was looking for a composite containment vessel, or DUA, for a partial core superconducting transformer. And he had approached Hugh and was trying to find someone that could actually do this piece of technology. It was something that appealed to me because obviously my power systems background, I could see where this could go to in terms of superconducting applications. And Hugh had the idea of how we could do it. So we thought, let's see if we can make a business out of this. There was also using composites for ultra high rotational speed centrifuges for oil and meat industries. So that was another challenge. So we started putting those two together. But a little bit more to it than that as well, because the next question you'd ask is why Christchurch? I was based in the North Island. Hugh had stayed in Christchurch after finishing university, and he was really connected to the very deep high-tech manufacturing base that's here in Canterbury.
Yes.
So we wanted to leverage that. We understood that collaboration and partnerships would be necessary for where we were going. And the other piece was University of Canterbury, rich provider of talented engineering students. And in my year, the majority of my cohort left to go offshore chasing jobs. And we felt it would be advantageous for New Zealand to actually have a base where engineers could come out of varsity and without leaving town could put their technology and innovative thinking into products that had a global impact without leaving home. Obviously every Kiwi wants to do his OE, but being able to bed people down in terms of that early place for technology development was a key driver for what we chose to do. So those motivators, along with the opportunity in that tech space, were the two bits that actually created the opportunity for Fabrum.
Yeah. And so your initial, ideas and opportunities, how did that play out? Often the what you planned for at the beginning, it's not necessarily a sort of a straight line from there to success.
No straight lines in this course, no, and I'm not sure if success sits there either yet. It's still a play in motion, but that focus in superconductivity we were probably ahead of the curve. New Zealand had a really strong presence in the superconducting industry globally. The government had supported it. IRL and others were leading that space globally. So it was a natural place for us to play. The opportunity to move the power industry forward at speed was a key driver. There were three key things in superconductivity. One is a wire, which is still a black science or black art. The containment vessel, which was a composite technologies we worked on, and then the provision of a cryogen, which is what pushed us down the path of making a cryocooler so you could have localized production of liquid nitrogen. So we nailed two of those, the containment vessel and the cryocooler, but the superconducting wire was a place we weren't going. And fair to say that was a limitation in those days of the acceleration of the superconducting industry. They're on top of it now, and it's now coming back, and it's, all of the areas that we thought it would go into, like superconducting aircraft motors, generators, etc. It's now starting to happen, which is great, but it's pretty difficult when you're about 20 years ahead of the market.
Incredible. So, for those that aren't familiar with superconductors and the broader opportunity, how could you simplify that?
So there's low temperature superconducting and high temperature superconducting, which is an interesting label because low temperature is at about 3 Kelvin, so 3 degrees above absolute zero, and then high temperature is at about 77 Kelvin, which is still roughly minus 220 degrees. Yeah. So cold. Yeah. And the reason you do that is there's certain materials that when you take to those temperatures, they have zero resistance, which means you can use a lot less of the material and you can put more current or energy through it. It has a bunch of other spin-off benefits in terms of when you overload it, it quenches and it becomes a choke almost. So when you're looking at limiting fault currents in a superconducting transformer, it's perfectly suited to that. So yeah, that's superconductivity. Most people would have glazed over by now, so we'll move on from that conversation. But it was a really good way for us to get deep confidence and capability in cryogenic knowledge and composite technologies. Part of that journey, we went up to America, looked at the space industry, looked at what they were doing with composite technologies and said, right, that's the quality and the level we've got to operate at, but we have to do it at an industrial price. So that Kiwi way of how do you really dumb down the process to actually take the cost out of it. So that was a core focus. We've done that. And interesting, your question was, what does that straight line look like? Well, it had a number of duck and dives and weaves in it. We picked up a bunch of IP in that superconductivity space, how to use composites and with helium, very small molecules. So how do you contain that with a porous structure like fiberglass? And then how do you manage heat events or pressure events with those technologies? So, fast forward 21 years and there's 20 odd patents that have been put in place, a multitude of trade secrets, and we're now probably confidently one of the world leaders in liquid hydrogen storage systems for 100% composite tanks for aviation application, which is a massive enabler for getting aircraft flying with liquid hydrogen. But on the other side of it, our cryogenic technology is now going into animal husbandry, human medical applications, remote high purity oxygen production for defence or humanitarian aid, deep research, cooling for detectors, right through to liquid hydrogen production plants, boil off gas management for LNG and hydrogen, etc., etc. So a long way from where we started with a partial core superconducting transformer for the university.
Yeah, so that creates lots of opportunities. What have been some of the most exciting ones over the years? You know, and I see sort of names like NASA and varying others mentioned when we read about you. How do those sorts of things come about?
The NASA one, I mean, you know, post the Christchurch earthquakes, we were doing some work in Japan for beam tube components out of composites, etc. And when the earthquakes happened, it was almost like the phone stopped ringing. I'm sure CNN said, told the world that Christchurch had fallen off the map.
Oh dear.
So it was an interesting change for us. It was actually how do we combat this? So Hugh and I jumped on a plane and did 27 flights in a couple of weeks and really pushed it out there to a number of potential and existing customers.
Yes.
And in one of those meetings, it was actually a conference in the US, we had a representative from NASA there who wanted up and said, hey, we're thinking of doing this. Is there an application for your cryocooler? And it was a CO2 sublimation system for Mars, a Mars lander project.
Yes.
And sort of said, that's interesting. So we came back and developed a system for them, which I think we did it in 4 months from concept, design, build, deliver, and it was successful. So that was one of those moments where you go, we just got a check from NASA. So that was pretty good. Rolls-Royce, doing a little bit of work with them, supporting some ceramic structures within superconducting applications. Again, conferences, working with other Kiwi companies as a NZ Inc. specialist team, going into superconducting conferences or cryogenic conferences around the world. That's our real connection point. So yeah, Rolls-Royce, NASA, and then of course you get the likes of Shell, where these really large marquees show interest and you end up doing projects with them, which is pretty exciting for a Kiwi company based in Christchurch. There's been a bunch more. We've done aviation motors, superconducting, high copper content electricals for groups around the world. First large-scale liquid hydrogen plant for a mining application. Yeah, it goes on.
What would you say have been the most challenging points? You talked about following the earthquakes that it seemed things dried up at that time. What would be the other inflection points? Because it's a long period of time that you've been in operation doing really cutting edge things. But if they're not all firing all at once or at the right time, that creates some pretty significant challenges, I'm sure.
Over that period, some might say we've chased shiny objects. There's that risk, but the way I'd rather look at it is that we've been very agile and we've shifted as the market's moved, or our capability is aligned to an emerging potential opportunity. So, over that time, we've got involved in supporting gas separation within electrolyzers for gas production, hydrogen gas production. And there's a real challenge when, we have this conversation internally and it sits well with some people, but not most. A lot of people like routine and known outcomes. When you live in an innovative space and you're committing to delivering outcomes that have never been done before, you've got a degree of confidence that you can get there, but it may not be the first solution. There might be a couple. So that means you operate at a high stress level around what's known, what's not. Failure is something that's not deemed failure. It's called proving a concept is functional or not. So you have to expect that you're not gonna do this thing in 4 weeks, 3 days, and the budget's not necessarily going to be exactly that. And that puts a lot of pressure on people because some people measure themselves against timely deliverables or budget deliverables, etc. And in this world, it's unrealistic to think you can do that. So you've got to be pretty brave in your own capability and your belief in what you can do. So the challenges in that are when you work with companies that live in the mainstream, but they're trying to adopt technology, they often don't get it. They don't get the rockiness of that journey and the lumps and the fact that it may not be the first solution that works, then you might have to actually go through some progressions of a product.
How do you take them on that journey?
You try and do it with absolute transparency, but it requires, like offshore especially, a lot of the companies we work with, like Siemens, Brooker ASC, Zero Avia, a number of aviation companies out of Australia, a pile of businesses out of the US, etc. They get it because they're doing it themselves, and you're a partner in their development, so they understand the challenges, and you can have really open conversations. When you come back to that more mainstream group that they're trying to transition into a new area, but they've got no understanding of innovation or the technology challenge, that chasm you've got to overcome, you operate with transparency. You try and give them a clear example of what the risks are and that timeframes are not timeframes, etc., but you do your best to meet them. And 99% of the time you're good, but you do have that, we've been doing this for 21 years. We've only had probably 2 of those bumps with customers that just don't get it. And you just got to work through it. And you either resolve it or you agree that you go your own ways. So it's a reality. It's not about failure. It's just about recognising that some companies are good for that journey and maybe others should stay in their lane.
So how do you price things in these types of scenarios where it works for you and it hopefully works for your customers?
I think it's fair to say that Fabrum over 21 years has carried a lot of that development cost. So unintended consequences. When we set the business up, we needed some machinery to do some specific applications, but our use of it was only about 3% utilisation, so therefore you go and find work that actually uses its other 97%.
Yes.
That starts creating this contract manufacturing business, and that becomes your cash cow, and all that funding gets poured into your IP development, your R&D, so you're offsetting a lot of customer projects with your own funding, and the benefit of that is you build an IP chest, which enables you to then converge that IP onto total systems. So reality is you've got to have a bunch of shareholders and a board that are confident that profit is not the measure of success. Maintaining financial capability is important, but you're not in this for a dividend. You're trying to build long-term value. So short answer is you fund the R&D out of your other activities.
Yep. Yeah, it does seem that there's a lot of that goes on, of getting, finding other things that sort of fill in the picture and then allow the innovation to be able to happen.
Yep. Yeah, it's a reality. I think we've worked with a lot of IP companies over the years as well, where we've been part of their IP picture. So we're developing capability for them, which they ultimately end up owning. Sure, we learn skills and we build competency out of that, etc. But what we did learn was it's not necessarily a good place to be, because what you do is you tie your success to their success. So over the last 7 years, we've become much more focused on our own product, our complete solution, so that you're not at risk of another team's ability to deliver outcomes. We back ourselves. We've never failed in a project over that 21 years yet, but we have definitely had some ramp-ups to a no-go because our partner hasn't been able to deploy their product into a market, even though our contribution to it was 200% successful.
That must be pretty hard to take when the team have worked so hard, and you get through really challenging obstacles, and then you find it's not able to be leveraged in the way that maybe everyone was imagining.
Yeah, there's definitely some heartbreak in it. I mean, we're fortunate we've got this incredible team of people in the business that are really focused on delivering change or value. We have this internal conversation around treading lightly. Everything we're trying to do is actually develop technology that enables humanity to do more with less for longer. So hence, tread lightly. And when you put a lot of your own personal energy into a project and then it fails because your customer can't get there, It's difficult. We had a project we were doing into America probably 13 years ago, and it had some massive technical challenges. And we were doing a very small part of it, and there were some issues in the total project, so we sat with the customer in the US and we convinced them that we could actually do the whole thing and we'd own the total output as a product and it would work. They signed on to that. We did that, and we got the first order. It was a significant order. It was around 50 items, and these items were good value. And we committed to it. It was a combination of rare earth magnetics, titanium, composite plate, etc. We pushed hard over a couple of months to build all this kit, and just about on delivery, some other IP ran out its patent life. So they pivoted to that as a known product and crashed the whole program. Oh. So basically we've got an instruction to feed it all through the metal scrapper. No. And that's, you've got this stunning kit that would happily sit in any architectural design studio. And you're scrapping it. So it's a little soul destroying, but that's the world, It's at the end of the day, the commercial market will only pay the minimum they can to get an outcome. Yeah. So you can't always control the output. And that was the issue with working with partners. So just coming back to that one again, which is why now we try and own our own future.
So what do you see that looking for? What are the opportunities, for instance, in liquid hydrogen? It seems to be that I've just been to the Aerospace Summit. There's quite a lot of interest there, but how big do you see the opportunities being going forward?
Oh, that's interesting. In New Zealand, I don't think we have an H in our alphabet. Hydrogen doesn't feature greatly in New Zealand. There's a couple of companies that are working with it for, say, trucking. For us, we see an absolute application for it, especially in heavy industry, long-range truck movement, aviation especially. So the hard-to-abate areas with other solutions. Liquid hydrogen's a high-density energy source or energy vector that can be used for propulsion systems, etc. So that there's definitely a use case there, and most of our activity is offshore. So Europe, US, UK, etc. Charging, and Australia are moving really fast with liquid hydrogen, and especially in aviation. Great application.
Why is there so much interest?
Well, gaseous is easy, especially if you're on the ground, but it's heavy. You talk about this ratio between the fuel storage weight to the weight of the stored fuel in it. Yes. Now, when you go 350 bar or 700 bar compressed gas, you've probably only got 3% of total mass is actually in the fuel. But when you go to a liquid, you can grow that fuel proportion significantly. And if you go to, say, what our technology is, which is 100% composite, so lightweight, vacuum insulated fuel systems, then you can grow that past 20% and significantly more, which is critical for aviation, where every kilogram counts. So what you want is most of your weight to be in fuel and less of it to be in the system. So hence why aviation works, and it's why you'll see other, like marine applications will go to that as well. So challenge with hydrogen, of course, everyone thinks about the Hindenburg and draws all these crazy analogies to it, but it is safe. You design into it safety systems. For some reason we're not there yet in New Zealand, but thankfully globally they are, and we've got some really great relationships going, especially with a couple of Australian aviation companies that are testing out our systems, and we're getting good results. And
what does liquid hydrogen, what are you effectively kind of competing with? You're competing with traditional batteries, and what does that picture look like in terms of why we would expect this to scale and become a lot more common in the future?
I think, like most things in life, there's a smorgasbord of opportunities, so there's no one size fits all. I mean, I'm an electrical engineer. Electricity, especially renewable electricity, is the absolute go-to. If life was only that, it would be great. However, when your extension cord's not long enough and you've got to move away from the power point, you need to find an alternate. Now, batteries have an application. We break it up and we say light and local. Is if you're carrying light loads and you're not going far, then batteries work. When you start going past about 100 kilometres in a day and you need to have payload to make your business profitable, then you start going to a hydrogen solution. And when you need to get off the ground and payload's critical, fuel weight's critical, and distance is critical, then you start going to liquid hydrogen. The alternates are batteries, but they don't play in those spaces. They're great for torches and Nissan Leafs.
And Teslas, come on.
And yes, of course, can't forget the Tesla. I thought the Tesla was just a mobile data acquisition system for imagery. But batteries have their place.
Yeah.
Fossil fuels still have their place. There's a lot of advances in minimising emissions, etc. So they have a place. Gas has its place, natural gas, etc. We're not trying to solve the whole world's energy requirement with hydrogen, but what we are focused on is there are areas that can benefit from it, and liquid hydrogen works really well for that 100 to 200 seat aircraft up to 1,000 nautical miles. And if you think about New Zealand, Australia, even Europe, that's a significant amount of flights.
Yes.
And if you're going, if they're turboprops and you're using fuel cells and liquid hydrogen, then you can actually use existing airframes. So the transition can be quite quick.
It's interesting. Tell us about what you've been, what you've done here in Christchurch, what you've got at the airport here.
Well, one of the challenges, of course, is when you're building liquid hydrogen products, is that you've actually got to be able to test them before you ship them offshore. So we've done a couple of really interesting projects this year. One for the US, which is a Boyle off gas system, so it captures from stored hydrogen. It wants to boil off, so it vents. So we capture the vent, reliquefy it, and put it back in the tank. So we built our own 100% Fabrum IP system there, and it's been shipped up to the US for testing. And we've just completed one for a university in Germany, and that's a liquid hydrogen production unit for use in a superconducting program, which is interesting. Before you send them, you've got to test them. So in conjunction with Christchurch International Airport, we are utilising some of their land beside the runway, where we've set up a hydrogen test facility. And what we do is we take our gear there, we operate it, we take it through full commissioning testing, clients come in, they do their factory acceptance tests there, and we make liquid hydrogen, because that's what those units do. And while we do that, we have a couple of our aviation companies come in with the tanks we've made for them, and we go through the tank testing, performance testing of the tanks using liquid hydrogen. And obviously we also provide refueling technologies and safety systems, etc. So we get a chance to test all that, prove it. So that's probably first of its kind globally, is where you've got a total systems manufacturer, integrator, working with customers on an international airport with actual aviation systems, especially 100% composite tanks. So a bit of a first. It's quite neat here to do that in Christchurch. And there's a number of companies that we obviously work with that are Christchurch-based or Canterbury-based that sit in that ecosystem.
Yeah. And why now? Why is now the time when these things are, it's all coming together?
So hydrogen, the use of hydrogen sort of went through this bubble. Probably Ukraine war put a focus on energy restrictions or potential loss of access to certain energy. So what's a replacement? Hydrogen, you take water, apply electricity, you can make hydrogen. We're not going to get into the discussions about the efficiencies and all that. There's a bunch of doomsdayers out there that'll always argue against it, as they probably do against fresh air. But the reality is that groundswell of interest that was people grabbing government funding has sort of faded away, and the real players are still there, the ones that understand the application. It is here as a future fuel, and in a number of applications it's a current fuel today. If you talk aviation, there's probably 30 plus aviator groups around the world that are moving with liquid hydrogen. They need solutions. There are technology challenges. You need a lightweight containment system. That aviation game's a long game, so you need to be at the front end of that to influence and inform what's possible. So hence why we're focused on that now. The second piece of that is where you've got the transferal of liquid hydrogen, the handling of it, the management of zero boil off, etc. That drives there's a technology void. We're in there filling it. And when you put it on an airport, for example, airports have to become comfortable with the handling of it, the use of it, overcoming the horror of the H molecule,
Yes.
all of that sort of drama. Yeah. So that needs to happen early on in the program, and we're doing it. So we believe that this technology is a great export opportunity for New Zealand. There was a smart fellow a number of years ago that did some stuff with the hydrogen atom. It came out of New Zealand, so we've got a fairly long relationship with this molecule.
Yeah.
And it's just another channel that's not an app. It's a real project, real product that involves a multitude of skills from manufacturing plus R&D, construction, etc., that can support New Zealand's fuel sovereignty, fuel independence going forward. Plus it can drive good jobs. It aligns with the Kiwis' need to fly. And it's a great way of building an export business, which we're already proving. That's why now.
Fantastic. Anything else to finish up? Anything else we should have covered or should add in?
In the innovation space, we are trying to find solutions, possible solutions to current and future needs. And to work in that space, you've got to have an open mind and not close doors too quickly. New Zealand comes out of the back of a really rich innovation, creative space. You can call it number 8, whatever, but we're renowned for it and we're very capable in it. The risk is that we have too many people closing doors and not allowing that process to happen. I think it's important that we maintain an openness because I think as a country our future prosperity is aligned to innovation. That's innovation in farming, innovation in primary products, produce, but also in technology. We've got we own a space, Rocket Labs prove that. We own a space. We're very clever as a country and we've just got to create and maintain those opportunities to do it. I am concerned that we're in a current climate where maybe that's not happening and that doesn't bode well for us into the future. So, it's off subject, but 21 years into Fabrum and having traversed a number of world firsts and a number of patents and clear IP positions, I'm pretty proud of the team we have and what we've achieved. I think it's in the DNA of Kiwis, and I think it's critical that we keep supporting this behaviour as a country for our own future prosperity. It's a little off subject, but I think it's an important part to understand, especially coming out of an aerospace conference.
Yeah, no, I really appreciate that. Well, thank you very much, Christopher Boyle. Looking forward to what comes next for Fabrum and to see the innovation continue and of course the all the outcomes that come with that. So thanks for your time.
Pleasure. Thanks for the opportunity to talk. Cheers, Paul.
Cheers. Well, I trust you've enjoyed hearing from Christopher Boyle. So much there to soak in from his insightful journey as an innovative engineer and entrepreneur. The New Zealand Business Podcast has been proudly brought to you by Gorilla Technology, the information technology services firm helping astute mid-size and smaller New Zealand organisations to move faster whilst minimising cybersecurity risks. Be sure to listen in to our other episodes featuring a who's who of New Zealand's most successful leaders, including founders such as Rod Drury of Xero, Cecilia Robinson of My Food Bag, Sir Peter Beck of Rocket Lab, Brooke Roberts of Sharesies, Sir Michael Hill, and many, many more. And remember that a rising tide lifts all boats, and you can contribute to lifting New Zealand's success by sharing a favourite episode or two with a friend or colleague. This is Paul Spain signing out. I'll catch you on the next episode.
The New Zealand Business Podcast, brought to you by Gorilla Technology, your strategic and proactive IT partner.